Hello, ladies and gentlemen, and welcome to Section 2.5, Implicit Differentiation. So before I get started, ladies and gentlemen, just remember you can pause and rewind the video anytime you want to. Please do pause the video sometimes to answer the questions so you can see what you do or do not know about the questions I'm asking. First question I want to ask, ladies and gentlemen, I want you to pause the video to do this, is what do the following equations have in common? You got y equals 3x to the fourth minus 6x squared plus 5. You got y equals the sine of the square root of x minus 3. You got y equals x squared over x plus 1. And you got y equals x to the third times e to the x. What do they have in common? Hopefully you pause the video. You answer that question. And the answer to this question, ladies and gentlemen, is simply they are all solved for y. They're explicitly solved for y. So finding the derivatives are easy. Well, relatively easy. The first one, we use the power rule, okay, to get this answer. The second one, we're using the chain rule, derivative of the inside, derivative of the outside. This third one, we're doing this using the quotient rule and simplifying. And this fourth one here, well, this is done using the product rule, okay? But you see, they're all solved for y, so we're able to solve for, and we're able to take the derivative using our rules that we've already learned. Question is, what if the equations are not solved for y, and y is not easy to get by itself? Well, that's what leads us to today's notes. So, ladies and gentlemen, Section 2.5, Implicit Differentiation. I want you to try problems 1, 4, 5, 11, 12, 26, 28, 32, 39, and 41A. Just try a couple of the problems, see what you can do. Maybe you can do more than I can show you. But it's implicit differentiation, so these will not have y explicitly solved for it. Okay? Now let's look at this. So far, we've been able to take to differentiate if the equation is explicitly solved for y, or f of x. Example, here we have y equals 2x to the fourth minus 6x to the third plus 1. Do me a favor, pause the video, take the derivative. Hopefully you've paused the video and taken the derivative, ladies and gentlemen. The derivative of this thing is y prime equals 8x to the third minus 18x squared. If you did this, you used the power rule to find this derivative. And you were able to use the power rule because guess what? It was already solved for y. We took the derivative of this with respect to x, and y was already solved for. Now it's pretty simple. Thing is, we will not always have an equation that's explicitly in terms of x. That is, the equation will not be y equals blah, 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 blah. It'll actually look a little bit more like this, when we have y to the third plus y squared minus 5y minus x squared equals negative 4. So you see, y is not by itself, and with the vast knowledge of mathematics that I have, ladies and gentlemen, honestly, I wouldn't know how to get y by itself. I really wouldn't know how to get y by itself. It takes a grandmaster of mathematics to probably get y by itself. It's not impossible. I just don't have the time or patience to do it. How do you take the derivative of something that looks like this? So we'll have to differentiate this thing with respect to x implicitly. Okay, and what does this mean? Well, what this means, ladies and gentlemen, is anytime you take the derivative of something that has a y in it, you're going to have to write y prime next to it, or dy dx next to it. What does that mean? Well, I'm going to show you in a second with a really quick example, something that you could do too. For instance, I want y'all to pause the video and take the derivative of y to the second power. Just take the derivative of y to the second power like you normally would if I put it in the board in class. Hopefully you paused the video. Did you write 2y? You should have, because that's using the power rule. However, This is a y, so we have to multiply this by the derivative of y with respect to x. Because see, y depends on x. Y is not just a standalone variable like x. X is an independent variable. It doesn't depend on anything else. Y depends on what x is. So we have to put y prime there because the change of y is something different. You could write this, or I prefer writing 2y times dy dx. It just looks fancier and more mathematical. But you could choose. Some people like this because it's easier. I will give you 4 steps to do implicit differentiation. Now, these 4 steps, you don't have to strictly stick to them. You can combine some of the steps. However, by combining some of the steps, you're still doing all 4 steps. Here we go, ladies and gentlemen. Guidelines for implicit differentiation. Step 1. Differentiate both sides of the equation with respect to x. In other words, just take the derivative like I've taught you with the power rule, with the quotient rule, with the square root rule, with any rule that I've given you. Just take the derivative like you normally would. However, don't forget, if you see a y and you take the derivative of something that has a y, make sure you put that y prime or dy dx. After you do that, collect all the like terms, everything that has dy dx or y prime next to it, put that on one side of the equation, and on the other side of the equation, you're going to put the other stuff that's just has an x, doesn't have a y in it. Step number 3, you're going to factor out a dy dx or the y prime. You'll actually physically factor it out. And step 4, you will solve for dy dx or y prime. In other words, you're going to get dy dx or y prime by itself. Okay? These are the 4 steps. Again, rewind, pause the video if you need to. The best way to see this is just to do an example. So I'm going to bring up the example that I showed you earlier, y cubed plus y squared minus 5y minus x squared equals -4. So I had to pause the video, take the derivative of this, remembering to put a dy dx or a y prime next to or multiplied by anything you take a derivative of that has a y. Hopefully you pause the video, ladies and gentlemen, and here we go. Ready? Let's do the first part, y cubed. The derivative of y cubed is 3y squared, using the power rule, times y prime, plus 2y, using the power rule, times y prime, minus 5y prime. Where did the y go? Well, the derivative of y is 1 times y prime. Now let's take the derivative of negative x squared. Well, you should just get negative 2x. Now some of y'all go, well, why don't we put a y prime here? Well, because we know what the derivative of x is. The derivative of x is 1. So we don't have to put that. Last but not least, ladies and gentlemen, what is the derivative of -4? If you said 0, you're absolutely correct. That was really fancy, right? All right. Now, ladies and gentlemen, notice I have 1, 2, 3 y primes, and they're all on one side of the equation. I need to get this guy who doesn't have a y prime. I need to put him over here. Or it could be a girl. Here we go. By adding 2x to both sides of the equation, ladies and gentlemen, I now have all the y primes on one side. I have everything that does not have a y prime on the other side of the equation. Third step is to factor out this y prime. So let's factor out the y prime. So if I take out a y prime, I'm going to be left with 3y squared plus 2y minus 5. Took out the y primes from each one of these terms. Now solve for y prime by simply dividing by this quadratic in terms of y by simply dividing by that on both sides, I get y prime equals 2x over 3y squared plus 2y minus 5. Ladies and gentlemen, you've successfully taken a derivative implicitly. You didn't have to solve for y, but look at that. Y prime is by itself. All right. Again, rewind the video, pause it if you need to. Yes, there'll be more examples, but the rest of them will be in the board in class, okay? So remember, I'd like for you to try problems 1, 4, 5, 11, 22, 26, 28, 32, 39, 41A. We'll do some of those in class, and some of them I'll assign for homework. I'll go, hey, do some of these problems. All right. So, ladies and gentlemen, the video is almost over. I do want to, however, put one more tiny note in your toolbox. I've always given you these rules that not that I've come up with, but rules that I think would benefit you, like the square root rule, like the e to the x, and the square root of a function rule and stuff like that. So I always try to give you these rules and these little tiny things, like if you take a derivative that begins with a c, a derivative of something with c in it, you're going to put a negative, stuff like that. Well, here's another rule. A rule from this section to remember: when you take the derivative of x times y, if you ever have an x times a y, and you're going to see that in several different places, there's a simple rule to remember, and that is the derivative of x times y is going to be, using the product rule, by the way, using the product rule, x times dy dx plus y. So, hey, well, what happened to the x? Oh, that's right. The derivative of x is 1. And a lot of people ask me, well, how come you don't write dx dx? Well, the derivative of x with respect to x is 1. The derivative of y with respect to x is not always 1. Okay, so we'll talk a little bit more about that when we actually do some stuff. But ladies and gentlemen, this is a rule, and you're going to see that, and you're going to see x times y a lot. So I want to make sure that you know, if you ever take the derivative of x times y, you could just simply write this. Or if you're using y prime, you could put, let me write that. Oops, I don't want to do that. You can put x, you can put x times y prime plus y. You could also put that if you want to. All right. That's it for the video, ladies and gentlemen. Thank you for subscribing to my channel. I appreciate it. I hope you all have a wonderful day. And remember, it's not the math you know. It's tutor that can help you with the math you don't know. Peace out.